Here we go. So, well, we've got the next thing that we're going to talk about. We've been talking about KC, which dealt with concentrations. And we're still going to be in the land of concentrations here, but we're going to add in a special situation called KSP. We've been talking about KP as well. KSP is not a component of P, okay? This is pressure. This is something different, okay? This is called solubility product. So you know how when we did back in the day when you were doing you're trying to figure out if something was soluble or not, you had your cations listed over here and you had your anions listed over here, and then you brought them together, and if they had an S it meant it was soluble, and if you had an N it meant it was not soluble. Well, that's all kind of a spectrum, okay? And the way you can determine if something's soluble or not is actually looking at this KSP value. So this is what you're going to, instead of looking at a chart and getting a nice N or S and making life easy, now you have to understand what this KSP is. Okay? So like we said, it's a pretty easy one to do because you don't have any reactants that you're going to put into the equation. So you don't have anything in the bottom of your K values when you're calculating it, because you've got your solid over here, and then your solid is turning aqueous on this side, and those are the values that you would put in for K because you don't include a solid in there. So it makes it a little bit easier because of that, but you know, it's, again, you don't have that easy definition of just soluble or not soluble. Okay. So we did have a definition in those boxes that was an SS. Okay. Those are considered slightly soluble salts. They have a dynamic equilibrium, meaning that some of the solids forming and some of it's going aqueous and back and forth. Okay. You actually did a lab that was similar to this back in regular chem. You actually used, instead of salt here, or NaCl, you used hydrochloric acid, and you added it to this. And then you saw that sodium or silver chloride formed. That was the purplish stuff that you had underneath the hood on filter paper, if you remember back a couple years ago. That it was one of the first labs you ever did in chemistry. Okay, so when we're calculating these KSP values, those solids are not going to appear in the equilibrium expression. They don't do that for this or anything else, in fact. So when you're trying to figure out the solubility expression, this is what that's going to look like. Okay, the AgCl is not going to appear in there because that's a solid, because the concentration of those solids is going to remain relatively constant. Okay, now we have on the next page here a listing of solubility constants. You do not need to memorize these. Any KSP value, you will either have to calculate on your own, or they will give you a table of them. Okay, so there's absolutely none of these that you need to have memorized. So if we were to try to figure out the KSP value for CAF here, okay, I think this is the one that I have on your sheet, yes? I don't know.
It's like 2 pages, in front of our thing in the AP Chemistry Solubility Equilibrium, like the National Math and Science Initiative.
Yeah, I got it.
It's down below the chart. Okay.
Yeah.
Is it calcium fluoride that is the one that I'm going to try to get you to do? Okay. So, all right. Derek, you good? You're on the right page? Okay. So if we wanted to figure out the KSP value, or if we wanted to figure out what these values are of these two things here, or concentrations here, or molarities, what we would do is we would find the KSP value for calcium fluoride. So we're going to go up to our chart. We're going to find calcium fluoride. We see that that is 3.4 times 10 to the negative 11. Is that what yours is, or did I change yours to 4? Okay. I have my 4s over here, and then it got moved over. Okay. So yours is going to be 4.0 times 10 to the negative 11. Okay. All right. That's going to equal, we're going to do, we remember what we do here. We do the molarities of these. Well, we don't know what that molarity is for this first one. So we're going to call that X. And we're going to call this one 2X. But what do we have to do to that guy because of the 2 here? You got to square it. Good. So 2 squared is 4. X squared times X is X cubed. Okay. Everybody good with my algebra so far? All right. So if I have this equal to this now, and I want to solve for X, I'm going to divide both sides. Remember, we've kind of combined that right here. I'm going to combine both sides, or divide both sides by 4. My 4s go away. And then how do I solve for X at this point? Take the cubed root. Anybody not know how to do cubed root on your calculator, come and see me and I can show you. Okay. That's one thing that I do know how to do on there. All right. So once we have the cubed root of that, you should end up with 2.15. That's ugly. Let's try that again. 2.15 times 10 to the negative 4. I'm going to check my math. What is my unit for that? What? What's my unit for this? Huh?
There isn't one.
Yeah, there is one. There isn't one for the KSP value, but what are we calculating here? What does X represent? Molarity. Okay. And that is specifically the molarity of what species here? What did X represent? Huh? Calcium. Yeah. Your X was the calcium ions. What do I do for the fluoride ions then? How do I solve for the fluoride? Yeah, I have to multiply this by 2, and that'll give me the molarity of my fluoride. That make sense? So I got 4.3 times 10 to the negative 4 for the fluoride. That's an ion. My negative sign's kind of going off to the side, but I think you got it. Yes? Anything there doesn't make sense. Ready to go with that? All right, next one. I have silver sulfate, and I think I typed, do you have this typed on yours here? Okay, good. All right. So silver sulfate is 1.2 times 10 to the minus 5. That's going to equal X And I should probably do 2x in the beginning because that's listed first. There. Okay, so see if you can solve this guy. Solve this for x. See what x is going to bring you. You okay? That is the molarity of the SO4. And so it gives me my silver. All right, see if you can set up and solve for the next one on your own. Bismuth sulfate is listed right here. This one doesn't work well. You can just get this set up, but I don't think your calculators will actually do the calculation because it gets so ugly with that value, if I remember correctly. So I just want you to at least get this set up, but don't try to throw it in your calculator because you're just going to error out. So how would you set this problem up to solve for it? Okay, so this is as far as I can get it without the calculator giving up on me. Okay, because that value is so high. Yep, Maddie. What did I do? I see you smirking over there.
Nothing. I was just laughing. I put it in and I got 0.
Okay, Maddie.
How do you know which KSP to use for the
For the first one here,
not the like for both questions?
they have to give it to you. I got it from the chart right here.
Oh, they give it to you?
Yeah, yeah.
I thought those were just other. So does that mean like the business sulfate goes into 2Bi plus 3? Like, is the arrow supposed to be between that?
Give it to me. What?
The arrows, are they supposed to be between the business sulfate and?
Oh, yeah. Yeah, these arrows should have been here. Did they get shifted over on your paper?
Yeah.
So they're in the right spots?
No.
They're not in the right spots. Yeah, the back and forth arrow should be here.
Then the question 2 is it the same thing with like the 2 AGs?
Yeah, well, this, I don't know.
Hey, look, I do have a question.
Yes, honey.
Where'd you get the 36?
2 squared is 4, 3 squared is 9. 4 times 9 is 36.
3 squared is 27.
Oh, gosh dang it. But it's easier math. I can do it in my head if it's not 27. Shoot. So 27 times 4 is 108. All right. You got me. No, it's still call me on them. You know I do it. Do it all the time. Well, let me unconfuse you and me in the process because, you know, I'm sorry. Sorry, so sorry. My bad. All right. Have I messed up anybody else? Have we cleared up all our algebra woes? I guess if I would look down at my answer book instead of trying to do stuff in my head. At any rate, this number is so stupid tiny, this stuff isn't going to dissolve. All right. We can move on. Ready to move on? All right. So, in practice, the KSP values are determined very carefully. They do measurements, blah, 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 but you got to remember your stoic. Okay. This is that woman that I made you listen to, the calculator video woman. Remember her with the drawl and the accent and everything? So that's why she's like talking to, well, you got to make peace with it. You know, you can imagine her southern drawl going with that. Okay. So we've got lead chloride here. Lead chloride is going to dissolve to a slight extent according to this equation. They have given us the KSP value here. So they want to know if the lead's concentration is X, then chloride's concentration would be 2X. Okay. So if this concentration, the KSP for the lead is this, then that means that we are going to have X here, and this would be 2X. So they found lead to have this concentration. Okay. They want you to calculate the KSP if your lead has this concentration. If the lead has that concentration, which would be X, then your chlorine would be 2 times that value. Is that making sense? Then you're going to take that value, and because of the coefficient, you're going to square it and then throw all of that in your calculator, and that's going to give you the KSP. All right. Ready to move on? Good. All right. Remember, moles over liters is what? Molarity. So don't let that confuse you. You will sometimes see that. You will also sometimes see it moles times liters -1. They'll throw you units like that as well. So be careful. All three of these things are the same thing. Moles per liter, molarity, moles, liters, -1. Good? Okay, so just be careful with that. We are going to calculate the KSP value for this. You are going to calculate it, and you will hopefully come out with that value on your calculator. Go. The molarity of the copper bromide is the same as the molarity of the copper and the bromine because they're in a 1-to-1 ratio. So for every whole thing you have here, you have one of each part. So if this is your copper, this is your bromine. So the concentration of the whole is going to be the same as the concentration of each part since it's in a 1-to-1 ratio. That makes sense? Maddie?
And you said it's the same, like the parts should be the same as the whole. But if we multiply them together again, they wouldn't equal.
Well, but that's to solve for KSP. That's a different ballgame. You're just trying to figure out initially what the molarity of each one of these would be. So if I have, how many pens here do I have? 2, right? How many pen caps do I have? 2. So the concentration of the pens is the same as the concentration of the pen caps. Okay, and the writing part. All right, so then all you have to do is just take this. Instead of typing this twice into your calculator, what's a faster way to do this one? Square it. Yep. So if you take this one value and then hit the square button, you should come out with this answer. That makes sense? You're going for time. Always try to find ways to save time. Okay? All right, let's look at the next one down here. We're calculating KSP from solubility. So again, they're giving us the KSP of this guy, of the whole thing. But now we've got more parts in there. Okay? So KSP is going to equal our bromine, our bismuth here, which is actually 2x what? Squared. And this guy is going to be 3x cubed. What does x equal? That number. So substitute that number in, and then you can solve for KSP. And you should get that. Come on with your calculator, my Padawans.
No.
Did you get this?
No.
I got a head nod over here. No, it hates you.
I just did that exactly. Oh, sorry.
I'm guessing you didn't do it exactly.
So it says 6 times 10 to the negative 75th.
Okay.
You might have cleared your calculator a couple times and didn't do it as one fell swoop.
Times 2. Yeah. And it's moving. And times.
You don't need to square root anything here. You need to square stuff and cube things, but you're not going to do any square roots of anything for this one. You have a hair on your back.
Oh, I got it. I was talking to Apple.
Okay, maybe not a hair, fuzzy.
You're driving me nuts. And I heard you all just like your hair or a fuzzy, and I find you to use it as a fuzzy.
All right, you ready to work? You ready to good? Everybody good? Ready to go? You're gonna become calculator like 1 with your calculator as you continue through the day. All right. So, relative solubilities then can be deduced by comparing the values of KSP, but you have to be careful. Okay. These can only be made for salts having the same ion-ion ratio. Okay. Remember, solubility changes with temperature. That's why you're able, that's a lot of your cooking. Okay. You want stuff to dissolve into things, you heat up the water. Okay. You want more stuff to dissolve, you heat it up more. You want some really sugary Kool-Aid, heat your water and make that Kool-Aid. It'll hold a lot more sugar in there if you heat the water first and make the Kool-Aid hot and then cool it down later. That's what Southerners learn to do with our iced tea. Okay. You get iced tea in the restaurant that's unsweetened up here and you want to sweeten it. You dump your sugar in there, it just right to the bottom.
It's horrifying the amount of sugar that goes into this.
Oh, Lord, honey.
It's terrifying.
Yep, it is. That's right. But we love our sweet tea down south. Okay. That's the first thing a little girl learns to make is sweet tea. Okay. First thing you learn to bake is biscuits. First thing you learn to make is sweet tea. We got sweet tea in our baby bottles. Y'all got milk? We got sweet tea. Okay.
My cousins have like 3 pictures of just straight sweet tea. Like,
Yeah.
we have like pictures of lemonade, Kool-Aid, and what? No, just sweet tea.
Yeah. Well, it's different ages because the longer, some people like it fresher and some people like it like a couple days old.
Oh,
And
we drink it so
oh yeah,
Like,
we
all
go.
3 pictures.
Yes, we will. Yes. Yes, my dear. We love our sweet tea.
I maybe get through 1 glass in a day, and I've
Oh.
had sweet tea.
Yeah, no. We love our sweet tea. All right, getting back on task. So my KSP value is given here. We can calculate the solubility of this calcium carbonate in pure water in moles per liter and grams per liter. Okay.
Pretty much.
All right. So I've got my calcium carbonate. That is going to be the KSP for that is given here. Okay. My reaction would have formed Ca2 plus CO3 2 minus. Right? So we're going to take that. We know our KSP value. Our KSP is 3.8 times 10 to the minus 9. That is going to be equal to what? What are we going to use to represent the molarity of this guy? X. What are we going to use to represent the molarity of this guy? And what are we going to do with those two x's?
Put them together.
So we got x squared. How do I find out the molarity of one of those species? Take the square root of this value. And that ends up being 6.16 times 10 to the minus 5. And that is moles per liter. If then, and that's for the calcium, if then I wanted to turn that into grams, all I have to do is multiply by the molar mass off the periodic table for calcium. And that would give me the grams per liter for the calcium one. And then if I wanted to figure it out for the carbonate, I would figure out the molecular mass for that and multiply that by this value to get the grams per liter for CO3 2 minus. Okay? Everybody should be comfortable with getting between moles and grams now. Yes? Yeah? Off the periodic table. So I want to spend our time working on this stuff versus trying to work on stuff that you already know. Does that make sense? All right. So the next one, we have the KSP value for copper iodate. Okay, we've given that. So that's 1.4 times 10 to the minus 7. That's going to equal this guy I'm going to represent with what value? X times, what about this guy? 2x what? And I got to square it. Okay. So that means then 4x cubed is going to equal this value. I want to get x, I'm going to divide by 4 on both sides, take the cubed root, and I end up with 0.0033 molar. And what is that? What ion is that? Is that the copper or the iodate?
It's the copper.
It's the copper. Okay. Now, that is the solubility at 25 degrees. It's going to be determined by the copper. Okay. That value will be lower than the iodate, correct? Because the iodate, I would have to take and multiply it by 2, which would be a higher molarity. So this is the solubility of this substance. When the copper reaches this value, it'll start settling out then. So we can add in to our water. So if we have a liter of water here, I can add in up to this point, this many moles per liter. I can add that many in. After that, it's going to start settling to the bottom as a solid. So it won't be able to hold any more of that material. All right. And I think that on your sheet, I said that we were done with these notes. Now you're going to flip over into the next section, which is the here.
We got 2 minutes.
We got 2 minutes. All right, but I can do this in 2 minutes. Okay. So this just essentially recaps what I did for you today in discussion. Okay. I just think that the lady from Texas does a little bit better job than these notes do. She goes into a little bit more detail and depth. And so I like her notes better. But this is just exactly the same thing that I went through with you. So for tonight, you're going to do all of this, I do's and the you do's. Okay, so 8 problems plus the first 2. So 10 problems for tonight. Got it? And remember, these QR codes you can scan with your phone. It'll bring up a video. Okay? So if you get stuck, watch the video. See, I told you I could do it.